Hey there, Netcoders. Welcome back to Netcode-Hub channel, where we simplify complex coding concepts. Today we are diving into an essential topic for developers working with databases. We're going to talk about database transactions. Imagine this, you are building a bank application, let's say a small bank application project. Now you know that in the bank application, at least the bank application must have these three features: withdrawal, depositing, creating an account, and unlogging. Now, if a user logs, let's say if a customer tries to deposit account, you must log it. If a customer tries to withdraw an amount in this account, you must also log it. So within every day, you can get a number of services that you have provided through the login. And in this case, both interfaces here, or these both methods, are very important for the process of the day. Now, let's say if a customer tries to deposit amount or even withdraw some cash and you could not log, there could be an issue, right? So you must make sure that these two methods are executed successfully before you can say user or customer has successfully deposited or withdrawn or whatever it is, the amount. So in this case, what is the right way to do it? That is by using database transactions. Maybe you might be asking, what is database transaction? Well, database transaction is a sequence of operations performed as a single logical unit of work. It guarantees these asset properties: atomicity, which states that all or nothing, either every step complete successfully or none of them do. So it means that now you are having two methods at stake now: withdrawal and unlogging. So if these two succeed, then we can say that the operation was successful. But if one succeed and one could not, then we should revert it so that we have none in succeeding. There must be consistency, so database moves from one valid state to another. And also, there must be an isolation, that is where transactions do not interfere with the other transactions. You may have a multiple transaction. Now, each transaction should be held in a separate state, no interference. And we have durability. Now with this, one transaction is committed, it saves permanently. Now you can see that when you're using database transactions, you must have a state whereby you can save the changes made. But when you save the changes made, although execution is going to happen, but if you execute the commit, that is where it stays permanently. So if commit is not executed in transaction, although you've called the save state, it's still not going to be persisted. So in this, in working with transactions, you must begin transaction, you must you save it, then you need to commit it. In case you have an issue, you have to roll back the operation. Now this is going to be handled automatically by the transaction interface. So let's see how we can integrate this in our project. I have a small bank application created which emphasizes on create account, withdraw amount, deposit, and login. Let's see how we can use this example to achieve the context of database transactions. So when you check over here, you can see from my solution, it is a web API in .NET 9, as you know. So we are using .NET 9 for now. Now, when you check our repository, I have an interface created which handles the accounts and also the login. So in here, I can see I have create account, withdraw cash, deposit, and now here we're just going to check if this account exists and also get account balance, which returns a decimal number. All right, so from that, you can see from the log, I have this add log and I have getting all logs. Now, when you check the implementation over here in the repo, you can see from here that I injected a DB context. So I created this DB context, and here we're going to create an account, and in here you can see we're going to deposit it. Now, after creating, we need to save changes. So maybe I can just save changes over here. Then from the deposit cash or deposit amount, you can see we're taking the account number as parameter, decimal 2 as parameter. That is going to be the amount, and in here we're going to make a search to the database to get the accounts. Then after that, we're going to update the balance and now save changes. And also we're doing the same for get balance. You see, we're only getting the balance here, which is in the decimal. The return type of this method here is also a decimal. So absolutely, it's going to pick it up straightforward. Then we check in is account existing. So as you can see from here, in case it does, we want to return not now that is true. But in case it doesn't, then you know what we're going to do, false. Withdraw cash, we get the same thing. So it's the same thing as for deposit. Instead of adding, you're going to do what? Subtract. Then get account. So we're going to call this. The reason why I made this here, because we are using this more than 2 times. So it means we can create a single method to handle that. So I'm using this method. I'm using it over here 1. I'm using it over here 2. And I'm using it over here 3. So that's the reason why I need to handle it privately. Then for log repository 2, you can see it inheriting from this interface. We are adding the log, and now we also want to get all logs. Now with this, there's an issue here. You can see we are not implementing database transaction. Now let's assume here if a user comes in and tries to withdraw cash. Now this operation is succeeded, so it has been saved. But when it comes to this login, it couldn't. This place succeeded, but this place isn't. Now, since we are having DB context, it's going to execute it and persist the changes while this is having an issue. So at the end of the day, you must see that when you go to our log for the day, we did not have any activity in there. But in the database, there was an activity which has occurred. And that brings the data inconsistency. So we need to make sure that this should match exactly with this. If this succeed, this must also succeed. If this failed, then this must also fail, so that we have them all succeed or none succeed. But in this, I'm implementing database transaction. When you check the controller, that's where I orchestrated this. I want to make this simple, so I did not include a service class interface to handle these services. Normally, that's where it's supposed to be done, but you want to make this simple as possible. So I created a controller, and that is why I'm doing a whole lot of work in here. Although it's not advisable, you can create a service to handle that. But well, never mind. Let's go on with it. You want to understand the concept. So we want to get the balance. As you can see from here, we call the interface and I get the balance. We first want to check if this account exists. If true, then we want to get the balance. But check the deposit. You can see from here, we want to deposit cash straightforward, and now we want to add it. We are having 2 methods here. One could succeed, one can also fail. Since we are not implementing transactions, there could be an issue here. The same thing applies to when you go to withdraw, because we are calling 2 methods after withdrawing log it. This could be an issue, or this could be an issue, but one will still succeed. Okay, that's all from that. You see, I have this login. Since you're using this login twice, I need to also separate it, and so I can map it, and I'm not using any mapping package, so we want to do that manually. So we are mapping it over here. Then for create, you see we want to create it, and that is all. Then for get logs, you want to get this log. So the main focus here is on this one, withdrawing and now depositing. We have 2 methods at stake. One could succeed, one could not. And how do we handle this? Well, that's the reason why I need to implement database transaction. So let's try to streamline this, or even improve the performance of this, the efficiency of this, using database transaction. And so let's go and create an interface for that, and let's see how we can integrate it to make this work perfectly. Now in the interface, let's add an interface here. Now with this interface, we want to implement 2 interfaces. That is a tax save changes and now IDB context transaction. Now this context transaction handles the rollback, the commit, and now begin transaction. So we want to use this interface. Let's get and create implementation for this. So in here, we create a class, and which is the unit of work. we're going to implement the interface that we created with two interfaces specified. We want to create an instance of this IDB context transaction. And in here, when we click on this, we call this begin transaction. We want to make sure, in case it is not null, then we want to assign it to a transaction. So we want to create a scope for transaction and want to return that. Now for save changes, we're going to save changes over here. Now once you're done with this interface, we need to go in there and register that. So in our program.cs, we're going to register this unit of work. After we are done with this one, the next thing we're going to do here is, instead of implementing save changes ourselves in the repo, we want to remove all this so we can orchestrate this through the service or the controller. So anywhere that you have save changes, we're going to remove it. Okay, so now that we are done with this, let's go and use this unit of work in our controller to make sure we persist the changes, we begin transaction, and we roll back in case we have any issue. So in the controller over here, we have an I account, that is the interface created. We have the log over here. So this is going to create, this is going to deposit account or withdraw account. After that, is going to log it. So after we are done injecting this, when you come here, you could see that from get account, we don't need to be using this because we are not performing any operation here. We want to only get it from database. Let's go to deposit. Now in here, you can see we want to perform two methods, or we want to call these two functions at the same time. I want to make sure that they become success before we can move on to the next one. So in that, we need to use transaction in here. So this is what we are doing. Now you can see from here, we are using this using statement so that at the end of this scope, this transaction will be disposed. Now you can see from here, we are sounding it with try catch block, as you know already. Now in here, we're going to execute this first. We're going to execute this second. After that, you want to make sure that we perform database persistence. So we want to update it or save it permanently. Now, when we do that, we want to commit this. Now, when we commit this, it actually tells the database to keep it permanently, what we've done over here. So this is like confirmation. So this is going to confirm what we have done here. If we do not do this, database or the data won't be persisted, although we've called this save changes, unless we call this. So it means this should be success, and also this must also be what? Successful. Now, in case we get to this side, it means this has passed on, and this also has passed on. After saving and there's no issue, we're going to get it over here. When there's issue, this is saved, this is added, this is also added. Try catch is going to happen. Then we're going to roll back the operation over there. So instead of adding the log or adding the amount or the withdrawing cash or depositing, it won't happen. It's going to roll back. So you can see we are having in transactions, we are having three states: begin transaction, we have save changes over there to save your changes, we have commit, second one, then the last one here is a rollback. So you can begin, you can commit, and you can roll back. Now rollback here happens when you have an issue, but transaction begins and then transaction commit. That is when you are done with your functions or the method that you want to call between. Good. Now once you have this, we're going to copy same over here. We go back to our withdraw because these two methods have more than one function to perform. So here we need to also create one transaction. After that, we need to commit and save it. Okay, so before we can return something to the user. So you can see from here, after we are done with this, we want to go in and return get account balance. So after you withdraw your amount, we want to get this account balance. Bear in mind that we created this requested DTO. Now this DTO contains is a record which contains two properties as payload: account number and the amount that you want to deposit or you want to withdraw. So we're using this model for both deposit and also withdraw. So in the DB transactions, I think it's clear now. We have to use this business transaction. After beginning it, we need to save changes. We need to commit it. In case there's an issue, we need to now roll back. yeah, so implementing DB transaction is quite simple. Now let's go in and run this application and check it out. So our endpoint is ready. I have already configured Swagger. So if I move it to Swagger endpoint, I can get access to the Swagger over here. Let me just quickly do that. Okay. So now with this, you see I have this get account. I've already added an account number here. So let's see 1, 2, 3, 4, 5, 6. This is an account number. When we try to get account, we must get the balance. So this is the balance that we have, 1616.67. Now within this, we try to deposit amount. We have 1616. So let's see if we decide to 1, 2, 3. Let's add something like, so you must have 266. So I can't credit it. Now with this, we can still go back and check it out. Then we have 2616. Okay. Also, we can go to the not create. We can go to withdraw. And our withdraw, we can provide same thing. Then let's withdraw like same amount. And like I see, we're going to have back to 1616. Now let's see, where do we have this? We must get this from the logs. So watch here. Now you have all logs that we've done. This is what we did currently. 1, 2, 3, 4, 5, 6. We deposited, you see the type deposited 1000. Then we made a withdrawal of also 1000. You see, so that is a log. Now you see that if I call this endpoint, 2 methods have been executed at the same time. Now let's go and introduce this. I want us to understand what the DB transaction is doing. So let's go introduce an exception here from the withdrawal. So here, after it has done with the save changes, let's throw new exception. Let's say error. Now with this error exception that we are introducing, save changes is going to happen. This is going to execute this database, but it will be waiting for this commit as a confirmation. So if this never gets called, it means this will be rolled back from here. So with the catch, we need to roll back. So we're going to say that transactions dot rollback. That is for withdrawal. We did the same thing to deposit. We need to roll back. Okay. Now we're going to put a breakpoint here. We can check here. It's going to work. This is where it matters. We want to put breakpoint. And now let's go in there and I'll run this again and check it out. Let me make sure that I have the log over here. That is what's going to guide us to check it out. Okay, so let me just put it. Now watch here. If I'm going to now withdraw cash, we have about 1616. Let's check it first. 1, 2, 3, 4, 5, 6. So we get the same thing. First, we're going to check if this account exists. If yes, then go and select the amount. So we get it 1616, right? We have 2 methods executed. Now, the next thing that we're going to talk about here is withdrawal. We want to check if the DB transaction is working. So 1, 2, 3, 4, 5, 6. Now we have 1616. So if I withdraw 1000.00. Now let's click on execute. Now check it out. So here we're going to, this has performed, it has been what? Subtracted. Now we have less amount. Then we're going to add it to the database. The log is also working. Now we're going to save it. Check here. So all this, because we are not having execute like add. This select command, select. Now the next click is going to execute it. Check it out. Next. Now this has executed it. Let's see. So you can see it has made an insert into this log. Right? Good. But let's see. After that, instead of coming to confirm the insertion, let's see what happened. We have an issue. So when the issue occurred, it's going to roll back. You see? Now after doing that, we're going to return with this exception. Now let's say we had execution. here, right? So you must assume data has been updated already. But let's go and see. We subtracted 1,000 from it, so you must have like 600 or so, because the balance was 11616. Now check it out. You can see it's still 1616. Have you seen? All the execution was made, but since it did not get a confirmation from the commit, the issue was, or the operation was rolled back. So it didn't. So, but as soon as you do this, as soon as we comment this, and I'll make sure this is working, let's run it again and check it out. After the execution of this, and the confirmation comes, then it's going to get subtracted. So that's the powerful of that. That's the power of what? The DB context or DB transactions. Let's check it out again. So let's go in and check it out once more. So that is a 1, 2, 3, 4, 5, 6 as an account number. I want to withdraw 1,000. Now I click on execute, and now it's going to get called from here. Continue on, and now let's see what happens. So currently you can see it was accessed. Now we have 616. When we go and check the logs, go to log, check. Although this log was called when we decide to subtract, but you see currently we have the 1,000 subtracted, and that is what we did now. This is the time, what we did. So it tells you that DB transaction handles from begin transaction to commit transaction. Now in between, all transactions that you're going to pass on or all method that you're going to pass between can get executed. But in order for persistence, there should be the commit. As soon as commit executes successfully, then all these records are going to be persisted in the database. So alright, netcoders, I hope this is clear. So that's a wrap for today's video. We've learned what database transactions are, why they are crucial for ensuring data consistency, and how to implement it in our project, which is bank app in .NET 9 using NT Framework Core. So you have now equipped to handle multi-step database operations like a pro. I believe that. Yeah. If this video helped you, don't forget to like it, subscribe if you haven't done that, and hit on the notification bell so you don't miss any of my content like this. Do you have any question too? Then put it in the comment below. Alright, so thank you for watching this, and I hope to see you next time. Till then, take care.